we can use these properties of limits that we just talked about a little while ago to find limits of polynomials. Now, one of the properties said something to the effect of the limit as x approaches c of f of x plus g of x, and actually this is a plus or minus, is actually equal to the limit as x approaches c of f of x plus or minus the limit as x approaches c of g of x. So I can break this limit up. Well, that's kind of nice because that just told us exactly how to find limits for polynomials. Because I can think of this as g of x, or I'm sorry, f of x, just as g of x. This is h of x. I can extend this out to as many functions as I want. And that's actually what I'm showing here. So the limit as x approaches c, let me erase a little bit of this so we can see it again. There we go. The limit as x approaches c, but c in this case is the number 3, of x squared plus 4x minus 1 is equal to the limit as x approaches 3 of each individual component. So this is b as x approaches 3 of x squared, as x approaches 3 of 4x, and as x approaches 3 of negative 1. See, all three of these were different properties. This was the power property. This is a constant multiple. And this is the limit of a constant function. So in this one polynomial, I'm actually going to use 4 of those 6 limits. One of them was to be able to break it up, and each of these are different properties. So to do this, to evaluate this, this is going to be the limit as x approaches 3 of x cubed, which equals 3 cubed. And then I'm going to add to it the limit as x approaches 3 of 4x, which is 4 times 3. And then I'm going to actually add to that the limit as x approaches 3 of negative 1, which is negative 1. So when I put all these together, I get this limit is actually equal to 3 cubed plus 4 times 3 minus 1. Oops, I'm sorry. I just realized here that miraculously out of nowhere I suddenly cubed this thing when it really should be squared. There we go. So this is going to be 9 plus 12 minus 1, which equals 20. So the limit as x approaches 3 of this polynomial, x squared plus 4x minus 1, is equal to 20. Now, in case you didn't notice there, something really nice kind of hopefully popped out at you while we're working on that limit. If we start talking about taking the limits of polynomial and rational functions, there's a theorem that says that if p is a polynomial function and a is a real number, then the limit as x approaches a of p of x, this polynomial function, is really nothing more than p of a. And of course, rather than a, we could have used c or k or anything else that represent any real number. So this would be p of c or p of k or p of whatever. Now, this also carries down to the idea of rational functions. If r is a rational function given by r of x, where r of x is p of x over q of x, p of x and q of x are both polynomials, and again, a or c or k, whatever, is a real number, then the limit as x approaches a of p of x over, whoops, this is supposed to be q of x, not a g, q of x. That's the limit as x approaches a of r of x, this polynomial function. That is nothing more than r of a, provided that q of a is non-zero. Again, we cannot have 0 down here in the denominator. So we can start putting all those ideas together to start finding some limits. So let's find the limit as x approaches 2 of 3x squared minus 2x minus 7. That's pretty straightforward because this is a polynomial. So this is just going to be equal to 3 times 2 squared minus 2 times 2 minus 7, which obviously you can fit around with and see, what is this? This is 12 minus 4 minus 7, which equals, that's 11, that's 1. So this limit is just 1. The second one, I need a limit as x approaches 1 of all this. Well, this is a polynomial function. Or, I'm sorry, a rational function. Notice this is a polynomial in the numerator and a polynomial in the denominator. So this is nothing more than evaluating this rational function at 1. So this is going to equal 1 cubed plus 3 times 1 squared minus 2 times 1 plus 1 divided by 1 squared plus 1. Now remember, the key here is this has to be a non-zero value, which it is, because 1 squared plus 1 is 2. So I know I'm in good shape there. So now if I evaluate the numerator, what do I get? I get 1 plus 3 minus 2 plus 1. So this is just going to be 3/2. So if you were to graph this and take a look at it as x approaches 1, you will see that the function is in fact approaching 3/2.